Hey everyone, welcome back to the channel. This is Rahul. Today we are tackling a really interesting problem from LeetCode, that is letter type possibilities. This problem will have us calculating the number of different letter sequences we can make from a given string of tiles. It's nothing, it's just like we are doing permutation. In that way, just think. So that's the thing. It's a great problem in order to understand counting permutations. So let's dive right in. If you are new here, just subscribe my channel for more coding contents like DSA using Java. So you can see here, you can go through it. I explained everything in detail. So let's start. Here is our problem. We have a string of tiles and each tile has one letter printed on it. We need to return the number of possible non-empty sequence of letters that can be performed using these tiles. If you go through this AAB, we are getting the output 8. So here are some sequences that we are getting from this AAB. That AB, here we have 2A, so that is creating another one, then 1A and 1B, then BA, AAB, ABA, BAA, like that. So it's nothing but just arranging in that way, like a permutation. That's it. For this AAA, BBC, it's 188. So it's hard to write the full. Means we can write single, means we have 3 2 1, so we have one C at first, or A, then 2A, then 3A, then 1B, 2B, like that. As in that way we can write the sequence as much as it can go. And here it's only one, so we have output 1. So to solve this, we need to count all possible sequence, including repetitions and different orders. So here is the high level plan. First of all, we have to count the frequency of each tile. This tells us how many times each letter occurs in the input. That's I first mentioned. We have 2A, B. So with this example, we can tell that. So we have to write the code in that way. Like we have to understand how many times each letter occurs in the input. Second, pre-compute factorials. Here, factorials helps calculate combinations efficiently, especially when we pick subsets of varying length. At last, dynamic programming or backtracking. For every possible length, we will calculate the number of sequences by adding tiles one at a time in all possible combinations. Now, let's write the code and I will explain everything in detail. So, here is our method numTile possibilities with our input string tiles. So, first of all, we have to initialize one variable um, array, which means this array will store the frequency of each letter from A to Z. So the size will be 26, which means the whole count of our English letters. So int, we will use the variable name counts, new 26. Now we need to create one factorial array, which means in order to recomputing factorials allow us to calculate permutations quickly. So int, I will name it as fac, new int. So we will take the length from tiles dot length plus 1, and we will initialize first one as um, means first index fac of 0 as 1, because 0 factorial is always 1. Okay. Now we are going through the um, we are going to compute factorials for all numbers from 1 to this tiles dot length. So for int I to 1 I less than fact dot length I plus plus. Now I think you may know the factorial formula. So fact fact of I is equal to, this is the formula we are using, I star fact of I minus 1. Okay, so once this done, come out of the loop. Now we have to count tail frequencies because we are going through the loop again to through the tiles string, and we have to come update the counts array. So for I to 0 I less than tiles dot length I plus plus. So here we have to um, compute update the counts array. The index we will give is like counts of tiles dot caret I minus a plus plus. Okay, here this index gives us the correct position in the array. Example, A maps to index 0 and B to index 1. In that way, again come out of the loop. Now we need to initialize another variable in order to store the count of permutations for each possible sequence length. So int length counts is equal to new int of tiles dot length plus 1, and we have to initialize it to one variable to represent the empty sequence. We will give the um, zeroth index to 1. So length counts of 0 is equal to 1. Now we have to check one some conditions here. So we will go through the loop again. So here we only process letters that actually appear in tiles. So if counts of I is 0, it means the letter is not present. If counts of I not equal to 0, Then we have to create one temporary array in order to store new permutation generated by adding the current letter to existing sequence of different lengths. So int, we will name it as temp tiles dot length plus 1. So we have to go through another loop here for in j to 0, j less than um, length dot counts, sorry, length counts dot length and length counts of j greater than 0 and increment j. Here for each length j that has permutation, we trying to add the current letter in all possible counts from 1 to its frequencies. So when we get into the loop, we have to write another loop, means just a nested loop, that's it. So for int k is equal to 1, k less than or equal to counts of I, k plus plus. So here we have to add the current letter k, k times to a sequence of length j, and we need to calculate the new sequence count using the permutation formula. So we will go through that now. Int, first we have to get total length is equal to j plus k. So temp of total length, which is equal to, so this is the equation. Total combination is equal to factorial of total length divided by factorial of repetitions. Okay, so length counts of j into factor of total length divided by factor of j. So once this done, come out of this loop, and we have to update the length count. Again we have to loop it, int j is equal to, sorry, not this loop, yeah, for int j equal to 0, j less than temp dot length j plus plus. So once all new permutations are calculated for the current vector, we add them to our main permutation array. That's we are doing here now. Length counts of j was equal to temp of j. So come out of the loops. Okay, now we have to initialize one variable means um, end ends to 0. So here we will do another loop starting from 1 means we have to skip the empty sequence means length counts of 0 and some more valid permutation of length 1 and higher. Now we have to return the result. This one holds the total number of sequences. Let's run it. It's working. So here I already mentioned how the logic working. Here our frequency at the starting as per the program I will mention. So when tiles equal to AAB, the frequency calculation, that's the first thing happening. It will become A gives to, I will just show here, that's better. At first our frequency, it will be show like A2 and B1. Okay, this one is for tiles is equal to AAB. Okay, after this we will compute of length 1. So length 1, it will be A and B. Length 2, it will be AA, AB, BA. Now length 3, it will be AA, B, A, B, A and BAA. So like this program is working, and at last we will get the ants as 8 means total count 1 2 3 4 5 6 7 8. So this is the way how this program is working. Okay, so why this approach is optimal? Okay, so this approach uses dynamic programming and factorial precomputation in order to avoid redundant calculations and everything. It systematically explores all possible sequence for every letter combination, making it efficient and easy. So when it comes to time and space complexity, for time complexity takes big of n square because we compute permutation for every possible length and character count. When it comes to space complexity, it is big of n plus 26. 26 I already mentioned. It's the size of the alphabet letters, total length, and the n means it is happened due to the counts, fact, and length counts array that we already use here. So submit it. That's it. It is much efficient than any code. So that's it for today's problem. We broke down the logic step by step and walked through the entire code, explain the problem statement, demonstrate the example. So if this helped you, please like, subscribe and share it with your fellow coders. See you in next one. Till that, happy coding. Thanks for watching. Bye.